In this video, I will show you the result of the implementation of reference laboratories that developed in Chernihiv Polytechnic National University as the part of the project Lab Discovery Engine, supported by NGI Search program and funded by the grant agreement number 10/10/97 69 364. Here on this slide, you can see the two human-machine interface that was developed in the initial stage of the project. And this human-machine interface describe the control elements and the scopes and charts for two experiments, buck converter and boost converter, that should be developed in Chernihiv Polytechnic National University in accordance to the project. Team of Chernihiv Polytechnic National University already developed the hardware, embedded software for the microcontroller, as well as the web application based on Vue.js that works together with Lab Discovery Engine, a remote learning management system that was developed in the project by partners from Labsland. Now I will show you how it works in our remote laboratory in Chernihiv Polytechnic. So the start page of the remote laboratory, as you can see the list of the experiments. Without authorization, user cannot access the equipment. So to have the access, user need to be authorized and authenticated. And now he can access for the experiment, for example, buck converter experiment. Access is provided and user have 10 minutes limit for the experiment. Here you can see the control elements and schematic diagram of the converter that developed in the project, the recommendation for the student, the oscilloscope for the visualization of the data on the load, and also chart for output voltage versus PWM control signal. The control works in two modes, automatic and manual mode. And for example, in manual mode, user can set the PWM level of the control signal and see the exact value of the output voltage and add this point to the chart. For example, for 8% PWM, the output voltage is 0. Let's increase the voltage and add another point. And as you can see, for some threshold level on the output, we can see the voltage that is not 0. When we will increase the PWM level, the output signal will be increased. And user, in this case, can add additional points to build, for example, chart and investigate the operation of this buck converter. How it's the output signal is related with the control signal, for example. This investigation can be done for many possible output filter capacitors and for many input voltages. And finally, for example, we can set more PWM level and reach maximum possible level around 97% of PWM control signal. So as you can see, there is some non-linearities of this chart, and this is because we have real equipment, not simulation, and the student need to analyze why, for example, this behavior is not ideal. Also, student can save chart and see this chart and investigate all this operation further when he is not using the experiment. Also, user can reset chart and start, for example, from start to investigate for another points, and also he can add additional points, and all these points will be added to the chart. Also, it should be noted that user can see the oscillogram of the real signal on the voltage, output voltage, and user can see, for example, all this pulsation that is caused by the PWM signal. For example, the output voltage for this capacitance is not so stable, and as you can see, there is some voltage swing from 9 to 9.1 volt. Also, there is some high voltage spikes on output. It's a real behavior of such converter, and the student can analyze why this oscillation, for example, occurs, and how they um, can be uh, explained in real experiment. Also, student can save this oscillogram and also analyze and investigate all these specialities after the experiment was finished. And also, operation is possible in automatic mode when the microcontroller is set automatically PWM level to stabilize the output voltage. And yeah, it can be seen that automatic mode is also works, but with the higher oscillation in the output voltage. And yes, so that's all for the presentation. When the student finishes the experiment, he can easily disconnect from the equipment and log out from the remote laboratory. Thank you very much for your time, and I hope this presentation will be useful and interesting for you.